All right, 2-3, solving systems of equations graphically. What is the solution of a system of equations? First of all, I'm going to draw 3 graphs at the top. They don't need to be very neat. They don't need to be very big. Just draw 3 graphs at the top, 1 in each column, please. So there's 1. Here's 2. And then a third one. And I'll give you a few moments to catch up. All right, in the first column on the first graph, just draw 2 lines that intersect 1 time, please. It doesn't matter where on the graph as long as they only intersect 1 time, please and thank you. On our middle graph, draw a line. Just 1 line, please. But I'm going to highlight it both colors. What does that mean? There's 2 lines there, even though it's only 1 individual line. There's actually 2 there. And yellow and blue make green, so if I did that right, it should be greenish colored, and it sort of looks green. So we've had where they've crossed once, where they crossed infinitely many. What's the third one going to be? Any thoughts? I'm sorry? Parallel. I like parallel. So draw 2 parallel lines, please. Nice, colorful notes. I like it. I see people still writing, so we'll wait another minute. I agree. After the long weekend, I get it.
I feel like this week's going to go by so slow.
Well, it's only 4 days, so hopefully not. And tomorrow's tomorrow's just a homework day. So, and then Thursday's notes and Friday's a homework day. It is? Are you bringing in cupcakes or brownies or donuts or what? Nothing? Lame.
Happy birthday.
I'll say if I remember. You said Friday?
I'm going to wear a sash.
I just saw one of my former students is wearing a sash today. I think it was Liana. All right, ladies and gentlemen, let's get back on task. How many? No, don't, please. I stepped on the scale today and it said 1 at a time. So, all right. How many times is this line crossing? This one. They cross 1 time, so there's 1 intersection. 1 intersection. All right, how many times do these cross? Infinitely many. So there's a special name for this. This book likes to call it identical. 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 There we go. And what kind of lines are these? They don't touch, so they are parallel. What is true about the slopes of these two? On these have the same slopes? They have different slopes. Just different is fine. Opposite means they would cross at 90 degrees. They're not, I didn't graph it thinking that. They're just different. Different slopes. What is true of these two? They have the same slopes. Do you need to write out slopes? Is there an abbreviation for slope? M. So if you want to use the abbreviation, go ahead. All right, and this one, obviously, parallel lines have the same slope. All right, obviously, these two have different y-intercepts. So different. If you want to use B, you can use B. Y-intercepts. How about this one? What's true about the y-intercepts? They are the...
What happens if mine have the same?
If what?
Mine have the same for all their intersections.
I don't understand.
Like they have the same y-intercept.
That's fine. Mine have different. No. Well, mine have different. I guess it's possible, Liam.
Yeah, mine's like right in the middle.
Okay, that's fine. I guess that is possible. Oh, so let's add that. Different or same. Thank you, Liam. Different or same. Because it could be the same. If these crossed on the y-intercept, it would have the same. So thank you, Liam. That's exactly correct. This one has different y-intercept. Okay. How many solutions does this graph have? Our first one. How many times does it cross each other?
One.
Just one. So there's one solution. So what is the solution of a system of equations where they cross? We just answered our essential question. So this is one solution. Now someone said it earlier on this one. How many solutions does this one have? Infinitely many. Infinitely many solutions. And how about the last graph? How many does it have? No solutions. All right, we need to learn 2 new vocabulary words before we can answer the next part of this. And honestly, I would highly recommend when you do your homework today or tomorrow that you open it to this page here and then do homework on a separate sheet of paper. It'll make your life so much easier. All right, new word, consistent. Consistent. A system of equations It's ENT. I've looked it up like 8 times today. A system of equations with at least one ordered pair. What do I mean by ordered pair? A coordinate, x and y. Very good. That satisfies both equations. And by satisfies both equations, like if you look at the first graph, that point right there is on both lines, correct? So it satisfies both equations. So it just simply means it shares a point. Hopefully that makes sense. All right, time for our other new word, independent. So in order to be independent, it must be a consistent system equations with exactly one solution. And this is the first 6 problems of your homework. Want to know if it's consistent. What's the opposite of consistent? Inconsistent. And what's the opposite of independent? Dependent. So that's what your first 6 problems of your homework are going to ask, and we're going to do some examples in a minute. But before we do that, let's look at this one here. Our first graph crosses one time. So consistent says a system of equations with at least one ordered pair that satisfies. Is there at least one ordered pair that satisfies this? Yes. So this one is consistent. Our middle graph, is there at least one point that is shared by both points, by both lines? I misspoke. Yes, so this one's consistent. And on this one here, Annalise, is there at least one point that is shared on the 2 parallel lines? No, there's not. Good job. So this one is inconsistent. Remember, parallel means they don't cross. So inconsistent. And now we need to determine if they're dependent or independent. Remember, independent says a consistent graph of equations with exactly one solution. How many solutions are there to this one?
2.
1. So this one is independent. Quit trying to mess with me.
So if we want
All right, so independent, it can only have one point that is shared between the 2. Does this one have more than one point that is shared? So this one is dependent. And as Annalise said, this one doesn't have any that are shared. So that would make it what? Dependent. Because independent is a consistent. Well, actually, is this one consistent? No, so it is not. It's inconsistent, so. All right, let's turn our page over, please.
So what do we put for the...
Nothing. Because if it's, in order to be independent, it has to be, yeah, so let's just leave it blank for now. And when we get to the homework, if it's inconsistent, it must be dependent. So we don't have to write anything. That's what I was actually just verifying, the way this textbook does it. So I tutor outside of school, and I received a text saying it's someone in Algebra 1 that goes to Calvary, and they're like, what's the gradient of the line? I never heard slope called gradient, but that's what it was. Just a different way of teaching. A lot of books do things different ways. It doesn't mean it's wrong, it's just different. So, example 1. I realize the title of this lesson was Graphically, solving graphically, but we're not going to solve example 1 graphically. So example 1, 2y equals 6x minus 14, 3x minus y equals 7. And this is the way your first, I think, 6 problems of the homework are just like this. First of all, if we were to graph them, which form would we want? Standard, point slope, or slope intercept? I wouldn't do point slope. You could, but I wouldn't. Because it doesn't give us any points, does it, Kyla? You got a 1 in 3 chance. So, alright, so I would personally do slope intercept. So if I have 2y equals 6x minus 14, I need to get the y by itself. How do I get rid of the 2? Divide everything by 2. So y equals 3x minus 7. All right, so we did the top line. Let's do the bottom line. So please write the bottom line. There are several ways we can do this. The way I would do it would be add y to both sides. And I would put the y in front. It doesn't really matter, but because we're about to get rid of this 7, because we want the y by itself. How do I get rid of a plus 7? Now I would put the y in front. So 3x minus 7 equals y. So I'm just going to rewrite it over here with the y in front. 3x minus 7. And what do you notice about these two lines? They are the same line. So like I said, on your homework, what it wants you to do is determine the number of solutions for each system. Then state whether the system of equations is consistent or inconsistent and whether it is independent or dependent. So how many solutions are there? Infinitely many, because it's the same line. So that's infinite many solutions. And then, like I said, I would have your notebook open so you can review back to it, and they're identical, correct? So that means that it shares at least 1 point, and independent means it's 1 point. Is this sharing only 1 point? No, so it's consistent dependent. So consistent dependent. Please no owing in class. Please no hurting in class. Jonna, do I need to send her out? Was she bad? All right. She gets 1 warning. You probably deserved it. So, all right. So that was example 1. That wasn't too terribly difficult, was it? Like I said, if you look at your notes while you do your assignment, it's not too bad. Dahlia, what are the chances of you seeing a question just like that on your test on October 6th? 99.9% chance. So unless for some reason I change the test before now and next Friday, you will see a question like that on your test. All right.
October 6th is next Friday.
Yeah.
Oh my God.
All right. Example 2. We're actually going to graph a problem. 5x minus y equals 3. Negative x plus y equals 5. In order to graph these, I personally would get the y by itself. So let's go to 5x minus y equals 3 and get the y by itself. If you want, you can multiply the whole thing by -1 to get rid of a negative y, but I just personally would add y. (5x equals y plus 3). And then we're trying to get the y by itself, so I would subtract 3. So that gives me y equals 5x minus 3. And then we'll do the same thing with the other line. Negative x plus y equals 5. Once again, we're solving for y because we want slope-intercept form. And because this unit is solved graphically, we're going to draw a little graph. It doesn't have to be a massive graph. And we're going to, I don't think you did any graphing in geometry of straight lines. Okay. Notice this graph is skewed to the top. I did that on purpose. All right, so my first point is 5x minus 3. So we're going to go down 3. 1, 2, 3. Oops. Go down 3 and put a point. From there, go up 5. 1, 2, 3, 4, 5. And to the right, 1. And draw your line. And because I'm an overachiever, I'm going to highlight mine. And now I'm going to graph the other line. I'm going to go up 5, 1, 2, 3, 4, 5. My slope is 1, so I'm going to go up 1 over 1. I'm going to graph my line. I'm going to highlight my line because I can. And this point right here is over 2, up 7.
Well, mine didn't cross like that.
All right, so on your homework, it says solve the system of equations by graphing. So the hardest part about this is finding out where that point is, so you need to try and be somewhat accurate. And we have the rest, we'll have most of today. We'll have some of today and all of tomorrow, so if you want to come and check your answers, you are welcome to. Kate, what are you doing? Thank you. We have one example left, and then you can be on your phone. All right, one example left for today. All right, can I turn the page? Anyone need more time? Hold on. Abby looks like she needs more time.
Mine's like up 1 over 1, but it doesn't like cross.
All right.
One, just like there.
It just has to be close. That's fine. All right, you good? All right, moving on. Last example for today. If that's okay with JoJo. I'll take that as a yes. I got side eye. All right, example 3. All right, it wants us to graph these and solve the system of equation by graphing. So it wants us to graph these. So in order to graph these, I need to get what letter by itself, what variable? The y. So let's get 7x plus 2y equals 16. All right, obviously subtract 7x from both sides. And then I'm going to divide by 2, divide by 2, divide by 2. Y equals negative 7/2 x plus 8. All right, we're halfway done. And let's look at the other one. Once again, we're solving for y, so I would get rid of a minus 21x by adding 21x. Did you say you can't wait to go home? I cannot wait. I foresee a nap in my future. All right, so we're trying to get the y by itself, so the negative 6 is multiplying, so to get rid of it, we divide. Well, 21 over negative 6 reduced. Is there a number that goes into 21 and negative 6? 3 goes into 21 how many times? And 3 goes into negative 6 how many times? So negative 2. And 24 divided by negative 6 is negative 4. All right, so on your homework, you don't need to have a perfect graph. What?
Is it a V?
Yes, it's negative 7/2 x. So just by looking at this, what do we notice about the slopes? The slopes are the same. So what kind of lines are they going to be? Do they have the same 'intercept? So they're going to be parallel. All right, I'm going to count by twos. 2, 4, 6, 8. All right, put a point, and now I'm going to go down 7. Remember, we're counting by twos. 2, 4, 6, 7, and over 2. 2, 4, 6, 7, over 2. Draw your line. And then we're going to draw our other line. And so we don't get confused, I'm going to highlight it. All right, my other line, I'm going to go down 4. And then from there, I'm going to go down 7. So 2, 4, 6, 8, down 7, over 2. And if we did this right, which I think we did. Yes, 1 second. Let me draw my line.
Wait, so we're counting like these.
Yep.
2, 4, 6, 8. Why does not know line?
Because I had to go, because once I went down 4, I had to go down another 7 and then over 2. So what do you notice about those lines? Do they cross? No, so they are, it wants to know how many solutions there are. How many solutions are there? Try again. Oh, you're all right, I'm sorry, I misspoke. There are no solutions.
I am confused.
Why are you confused? What's confusing you?
Why were you saying lines?
Well, because on the first graph, we went up 8, right? Down 7 over 2. On the second graph, we went down 4. And then from the 4 below, I had to go down how far? Another 7 and over 2. So from this point here, I had to go down 7 over 2.
So the 4 is
That's my y-intercept.
so -4.
Yep, -4. And then I had to go my slope, rise over run, which in this case it's negative, so my rise is actually down 7 to the right 2. All right, ladies and